given that we now have an understanding of the graphs of linear equations, we can now extract some information given 2 points of a linear equation, or given 2 random points of a linear equation. So if the first thing we can do is, if we're given 2 points, we can actually find that slope of that equation. And to do that, we're going to use the following information. Given the points x1, y1, and the point x2, y2, we can find the slope of a line using the following formula. So we have m. Now the letter m comes from the formula y equals mx plus b, where m is our slope. So that's why this formula is set equal to m. So our slope, we can find that by taking our y2 value, so whatever this value happens to be of a point, and then we're going to take our other y value and find the difference. And we're going to subtract y2 from y1, and then divide that by the difference of x2 minus x1. And then the other formula we're going to be using is, or the other thing we're going to be doing in this section, is something called the midpoint. Now the midpoint is the point that is directly the middle point between 2 given points. In other words, the midpoint is the average point that lies between 2 given points. So to find a midpoint, we're going to use the following expression. We're going to add up the x values of the point divided by 2, and add the y values of the point and divided by 2. So this makes sense because before we said that the midpoint is the average point. So recall, if you want to find like the mean or the average of something, you add up all the terms and divide them by how many terms that there are. So when you add up the 2x terms and divide it by 2, you're finding the average. Same thing, you're finding the average of the y terms when you do this. So, and if this idea of a midpoint is a little bit confusing, I can draw here real quick what this means, what this looks like visually. So let's say we have point A here and point B here. If you wanted to find the midpoint between point A and B, you can use this expression, and what that'll get you is you'll get like a point maybe about here. So this point, this blue point, is the midpoint. It's the point that's directly in the middle of the 2 points. So that's what this expression is doing, is it's finding the point that's directly in the middle of the 2. Alrighty, so let's dive into some examples. So in the following examples, let's determine the slope and the midpoint given the 2 coordinates. So I'm going to first find the slope, which recalls m equals the difference of our y values, so y2 minus y1, over the difference of our x values, x2 minus x1. So here, this first point, 4 is our x1 value, and 9 is going to be our y1 value. And then here, 6, 1 is going to be x2, 6 is our x2 value, and y2 is our 1, or y2 is our, or 1 is our y2 value. So let's plug that in. So we have 1 minus 9 over x2, which is 6, minus x1, which is 4. So we get 1 minus 9, which is negative 8, over 6 minus 4, which is 2. And negative 8 divided by 2 is negative 4. So that is our slope. We have a slope of negative 4. And now let's use this midpoint expression to find the midpoint that lies directly in the middle of the 2 points. So we have x1, which is 4, plus x2, which is 6. We're going to divide all that by 2. And then for our y values, we have y1, which is 9, plus y2, which is 1. And we're going to divide all that by 2. So this equals 4 plus 6, that's 10. Divide that by 2. 9 plus 1, that's also 10. And divide that by 2. Well, 10 divided by 2 is 5. So we get the point 5, comma 5. So the point 5, comma 5 is directly the middle point of these 2 points. So this is the midpoint, or this isn't the midpoint, but 5, comma 5 is the blue point of these new set of points. Alrighty. So for example, number 2, we have negative 5, comma 15 and negative 10, comma 18. So our slope, going to take our y2 value, which is 18, subtract our other y value, which is 15, and divide that by our x2 value, which is negative 10. And then we're going to subtract negative 5, because that is our x1 value. So now that we got that, 18 minus 15 is 3. And then in the denominator, here we have negative 10 minus negative 5. And recall, anytime you subtract a negative, that changes to addition. So we have negative 10 plus 5. And that ends up becoming negative 5. Oops. And that is our slope. Now for our midpoint, we add up our two x values. So we're going to have negative 5 plus negative 10 over 2. And then for our y values, we have 15 plus 18 divided by 2. Well, negative 5 plus negative 10, recall whenever we add a negative, we end up subtracting. It ends up becoming subtraction. So what we really have going on here is negative 5 minus 10. And negative 5 minus 10, well, that's just negative 15. So we're going to get negative 15 divided by 2. And then 15 plus 18 is 33. We're going to divide that by 2. Well, because negative 15 and 33 aren't even numbers, they aren't divisible by 2, so we can just say that this is our midpoint. Alrighty. So for example, number 3, this one is a try on your own problem, so I will read this out loud, and then once I read it, I encourage you to pause the video and try this on your own. Alright, so it says, you are mapping out a secret trail on a coordinate grid. You have already discovered that the midpoint of the trail is at the point negative 1, comma 1. And one end of the trail is at point B, which is 2, comma 0. To uncover the hidden matching point on the opposite side of the midpoint, you must graph the line that runs perfectly through both the midpoint and point B. So your mission is to find the missing point that lies the same distance from the midpoint as point B, which will reveal the other end of the mysterious trail. And I give you a hint here. Your hint is to begin by calculating the slope of the line that connects those two known points. Alrighty, so assuming you have given this a go and you try to identify the other end of the mysterious trail, or the coordinate point of the mysterious trail, let's go through it. So our first step is going to be to find the slope that connects these 2 points, the midpoint and the end of the trail. So we have x1, y1, and then x2, y2. So I'm going to take 0, y2, minus y1, divide that by x2, which is 2, minus x1, which is -1. 0 minus -1, well, that's just -1. Or, sorry, 0 minus 1. 0 minus 1 is just -1. And then 2 minus -1, well, because we have, because we're subtracting the negative, this becomes addition. So we have 2 plus 1, which is 3. So this is your slope. Sorry, that's not your answer. That's your slope. So now that we have the slope and these 2 points, we can graph this linear equation. And when we do this, we can find the other missing point. So we have x, y. Let's do 5 dashes. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So let's plot the point B, which is 2, 0. Point B is here. And then we have the midpoint, which is -1, 1. So -1 in the x direction and up 1 in the y direction. So we know that this here is our midpoint. And we're given point B, which that is here. And point B is on the one of the ends of the trail. Now we want to know the other end, which since one of the ends is here and this is your midpoint, we know that the other end has to be somewhere here. And we can find this other end by using the slope that we found. So let's do that. So because we have a negative slope, we're going to go up 1, positive, up in the positive y direction. But to make this a negative value, we have to go left 3, because a positive divided by a negative is a negative. So we're going to go up by 1 and left by 3. Oops. This isn't directly aligned. There we go. So this is our other end of the trail. So here's our linear equation. Here's our relatively linear trail. But because it's a trail, actually, our line will only run to here, to these points, or a trail. So this point, well, that's going to be 1, 2, 3, 4, -4, comma, 1, 2, 2. And that's your missing point. So let's call this point, I don't know, let's say it's point A. So our missing point, the other end of the trail, is at the point -4, 2. That's your answer.